Okay, so what we're doing today is this is a recording for section 4.03, Other Forms of Quadratics, for Wednesday, January 24th, 2018. And I am recording this, and I'm going to send this out over email and put it in the course so you guys have access to it. And just a reminder that I am not going to be here on Wednesday, which is why we are doing this lesson today. Tomorrow we will meet up and do 4.04, and then Friday we'll do 4.06. So our learning target for today is I can graph a quadratic function in factored or factored form, and then also I can graph a quadratic function in vertex form. So far we've talked about standard form, but now we're going to talk about other forms. So this is going to be a really short lesson because it's pretty simple. So graphing a quadratic in factored form. So the factored form of a quadratic, the general form, is f of x equals a times x minus r1 and x minus r2. So this is one root and this is the second root. That's what those r's stand for. Okay, so this says graph the quadratic function f of x equals 2 times x plus 1 x minus 3 by finding the following key features: axis of symmetry, vertex, x-intercepts, and then the 2 points on either side of the vertex. So in order to do that, let's look at this first. Okay, so factored form of a quadratic is f of x equals a, like I said, x minus r1 and x minus r2. To graph this, you need these characteristics. If it opens up, if a is greater than 0, if it's a positive number. If a is negative, it opens down. Okay, it has x-intercepts r1 and r2. So positive r1 and positive r2. And then the axis of symmetry is x equals r1 plus r2 over 2. So you add those two roots together and divide by 2. So let's go back and look at graphing this. So before we can graph, we need to find the key feature. So the x-intercepts are this guy and this guy, the opposite of what those are. Because if I set those equal to 0, like we usually do, it will give us our roots. So we have x equals negative 1. Oops, sorry, hang on. Negative 1. And then x equals positive 3. So those are our x-intercepts right there, negative 1 and 3. The axis of symmetry is where we add those two together and divide by 2. So it's halfway between the roots. So negative 1 plus 3 is 2. 2 divided by 2 is 1. So that's our axis of symmetry. Okay, our vertex, we use our x value here of 1, and we plug it into our function to find the y value. So we're going to plug in f of 1 equals 2 times 1 plus 1 times 1 minus 3. All right, so here we go. 2 times 1 plus 1 is 2, 1 minus 3 is negative 2. 2 times 2 is 4, 4 times negative 2 is negative 8. So the vertex is 1, negative 8. Okay. 2 points on either side of the vertex. We can just plug in some values to graph it. So I can plug in 0 to find the y-intercept, and then there'll be another point too. So before we do that, let's go ahead and move on to an actual graph here. So this is a different function altogether, but we're going to still do the same thing. Hang on one second. My music is like way too loud. Okay. So sorry about that. So our x-intercepts, again, we're going to take each of these and set them equal to 0. So x plus 3 equals 0 and x minus 5 equals 0. So we have x equals negative 3 and x equals positive 5. There we go. So those are x-intercepts. So negative 3, which is down here, and positive 5 right there. So I drew 2 dots there. So axis of symmetry is going to be negative 3 plus 5 over 2. Negative 3 plus 5 is 2. 2 divided by 2 is 1. So 1 is right here. So we're going to draw our best vertical straight line, which is not going to be easy. Okay, we did it. We tried our best. So, you know, that's our axis of symmetry right there. Axis of sim. Okay. Vertex, we take that x value and we plug it into our function to find our y value of our function. Oops. There we go. So negative 1 plus 3, and then 1 minus 5. All right. So we have negative 1 plus 3 is 4. 1 minus 5 is negative 4. So negative 4 times negative 4 is a positive 16. So our vertex is at 116, which is right there. Okay. And this graph opens down because our first little number up front is a negative. Okay. This number right here is a negative, so it opens down. So now let's find some more values. Let's figure out what's happening when x equals 0. Let's see if we can find the y-intercept. So let's plug in 0. 0 plus 3. 0 minus 5. So 0 plus 3 is 3, so we have negative 3 times negative 5, which is a positive 15. So we have a value right there. And since that axis of symmetry acts like a mirror, we know there's another value right there. Okay, and so now we can draw as best as we can on the computer because it's really hard to draw on the computer. General idea of what the graph looks like. Okay, so let's look at another form. So that's factored form. Let's look at vertex form. So vertex form of a quadratic is f of x equals a times x minus h squared plus k, where a does not equal 0. The vertex is hk, so that's really, really important. The vertex is hk. The axis of symmetry is x equals h, so these two numbers right here are basically what tell us everything about this graph. Okay, so x squared is the parent function of the quadratic family. Every quadratic function is a transformation. So we'll talk more about that later on. We're just going to focus on graphing right now. So what is the coordinate of the vertex for the quadratic function? So remember, we have f of x equals a times x minus h squared plus k. And our vertex is hk. So one important thing is we're going to take the opposite of whatever this number is. Okay? Since it says minus h, we want the opposite of that for positive h. And whatever this is, we're just going to take it at face value. That's going to stay the same. So here's our two numbers that we're concerned about, negative 5 and negative 3. Since that is negative, we want a positive value. We're just always going to take the opposite. And then negative 3 stays the same. So our answer is C, 5, negative 3. Okay. I have one more example for us before we end our session today. So graph the following quadratic function by finding the key features. So the vertex, so again we're taking this number and this number. Okay, that positive 4 is going to change to a negative 4, but that negative 2 is going to stay the same. So our vertex is at negative 4, negative 2. Right there. The axis of symmetry is that x coordinate of the vertex, so x equals negative 4. So we're going to try and draw. It's easier if I do it this way. There's our axis of symmetry. Okay, our y-intercept, let's find our y-intercept by plugging in 0. So 2 times 0 plus 4 squared minus 2. So 0 plus 4 is 4. 4 squared is 16 times 2 is 32 minus 2 is 30. So we're not going to be able to plot that one, but that's okay. Let's plug in negative 6 and see what happens when we have negative 6. So 2 times negative 6 plus 4 squared minus 2. Negative 6 plus 4 is negative 2. Negative 2 squared is a positive 4. 4 times 2 is 8. 8 minus 2 is 6. So at negative 6, we have 6. And then since we have our axis of symmetry acts like a mirror, we know there's another point there. Let's plug in negative 3 and see what happens when we plug in negative 3. So I'm just writing all over this board, which is totally fine. Negative 3 plus 4 squared minus 2. All right. Negative 3 plus 4 is 1. 1 squared is 1. 1 times 2 is 2. 2 minus 2 is 0. So at negative 3, we have 0. So there's one there. There's going to be another one right here because it acts like a mirror. Oops. I told you I'm not very good at drawing graphs on the computer. Maybe if I go down this way. Nope, still terrible. It's really hard to draw these on the computer. All right, so there's our graph. As good as it's going to get. Yay! All right. So your next steps are to go through all parts of lessons 4.03 if you haven't already. Take the 4.03 quiz when you feel ready. If you need help, come to the help session tomorrow at 10, so 10 a.m. tomorrow. And have a great day. So I'll see you guys tomorrow.